Okay. Where are you guys going to start? You're going to start with 3.1. What are you going to say? This is a vector problem. You don't say it, but what are you going to write? I said always choose up as positive. So what do we start by saying for 3.1? Upwards is positive. Now, what do they say? Let's read it. Stone A is projected vertically upwards at a speed of 12. So here is stone A, it's projected upwards at a speed of 12 meters per second. What is the next thing, guys, we must do? We must write down our values. Our values. What is 12? Which is it? Initial value? Final velocity? What is it? It's the VI. So because we don't want to get confused, we write VI equals plus or minus 12. Is it going up or is it going down? It's positive 12. And then meters per second. Okay, they ask us, they say, it's projected upwards at a speed of 12 from a height, h, above the ground. Okay, so there is h above the ground. Let's not worry about that. Let's get to the first question. Ignore the effects of air resistance. Didn't we say to do that? Ignore resistance. You can't do these problems. Equations of motion don't work if there's resistance. Okay. Calculate the time taken for the stone to reach its maximum height. Okay, what do we know about the maximum height? What is its V final at the maximum or maximum height? I heard one right answer. What's V final? 0. Does that make sense? Does that make sense? They're asking a question about when it reaches its maximum height. Am I asking too much to say that is when it's stopped? And then it's going to start going negative again. Okay. So V final is 0. What is acceleration in all these problems? In which direction does it act first of all? Upwards. Does acceleration, watch it, I'll show you. It's naught. Now let's let gravity work. Which direction does it always work? It's always down. Gravity acts down. Acceleration due to gravity is down. What is its value? Let's write it. We said it's 10, but it's actually 9,8. Okay? Is it acting in a positive direction or a negative direction? Don't get it wrong. It's negative because it's down, upwards is positive. So it's minus 9,8. Now let's just do it by mental arithmetic. How long do you think, if something is projected upwards at 12, what is it going to be? Let's just do it. 12. What is it going to be after 1 second? 2 plus 2. What is it going to be after 2 seconds?
7.
Minus 8. Right? So what, and they're asking us for delta t. How long does it take? See, that's the question. Delta t, calculate the time taken for the stone to reach it. So what is the answer? It's somewhere between 1 second and 2 that it stops. Can you see that? Watch it again. 12. Positive. What is it after 1 second?
2.
It's 2. But after 2 seconds, it's going down. So it must have, in the meantime, between 1 and 2, it's gone up a little bit, and then it's gone down 8. So what do you think, if it goes up 2 and down 8, how much time do you think it spends going up some more? Less time or more time than half a second?
Less than half a second.
Less than half a second. So the answer is going to be about 1.2 seconds. So I'm expecting that answer about 1.2. Make sense? See, I'm just working out mental arithmetic. But now, so we know we've got to find delta t, so you put question mark. Now, is there anything else we know? No. So let's go to our equations of motion. What of these equations can we use if we've got V final is 0, V initial is plus 12, A is minus 9,8. Do you see that we can, this equation works for us, we can work out delta t. Do you see that? I didn't even have to go through the other four. I can immediately see we've got that, we got that, we got that, and we need to find that. So that's the perfect formula. I don't have to think, I don't have to work it out. Isn't that nice? My brain is hardly fried at all. So let's work it out and let's see if we get about 1.2.
So if you use the bottom line, would it
We
work?
could, we don't know delta y. So we can't use that one. We don't know delta y, we can't use that one.
So what does delta y?
Delta y is the distance it goes. I just want to check that I've got my formulae correct. Delta y, delta y, delta y. Yeah, three of the formulae have got delta y. So there's only one formula that I can use and it has to be that one. Won't you guys now work it out? Just work out the answer. So we're going to, the next thing we're going to do, we choose our formula. V final is V initial plus A delta t. And we plug in our values and let's see what delta t comes to. By the way, if you ever get a negative delta t, it either means you've discovered time can go backwards, which means you're going to get a Nobel Award, or you're wrong. One of those two. So anytime you get delta t negative, you're either a Nobel laureate or you're wrong. And I know what my money is on. So let's do it. V final naught is V initial is 12 plus minus 9,8 times delta t. That is plus 12, right? Yep. Taking it to the other side, minus 12 equals minus 9,8 delta t. Dividing both sides by 9,8. That cancels 8 out. And what is 12 divided by 9,8?
1,2.
Sorry, it's both minus 9, minus, and then you say it's exactly 1,2 seconds. And there we go.
So can you tell me how you find VF again?
Because they said to reach its maximum height. Now you always have to remember its maximum height it stops. And that is when its velocity is 0. It's always 0 when it reaches its maximum height. Make sense? So can we go to question 3 of November 2018, last year's paper? Much easier question. Okay, in a competition, we'll get back to this question. Participants must attempt to throw a ball vertically upwards past point T marked on a tall vertical pole. Point T is 3.7 meters above the ground. Point T may or may not be the highest point during the motion of the ball. One participant throws the ball vertically upwards at 7.5 meters per second from a point that is 1.6 meters above the ground as shown in the diagram below. Ignore the effects of air resistance, okay? There you see that again. In which direction is the net force acting on the ball when it moves towards point T? Is the ball, although the ball is being thrown upwards, what force is acting on the ball? Gravity. What direction is gravity? Down. So what's the answer to in which direction is the force acting on the ball when it moves towards point T? It is downwards. It's the force of weight downwards, making it go slow. So the answer would be choose downwards, give a reason. The force is gravity which acts downwards, or weight. Now guys, isn't that lovely? Can you see that this question is actually easy peasy? Now let's look at question 3.2. Calculate the time taken by the ball to reach its highest point. And it was thrown upwards. Here's the problem. This is 3.2. It was thrown from a building of 1,8 meters. That's, by the way, delta y is 1,8 to start off with. But it's thrown upwards at 7,5 meters per second. Now, come on, let's do this together. 3.2.
So it's 1.6.
It's thrown upwards at 7,5. One participant throws the ball upwards at a velocity of 7.5 from a point. That is 1,6 meters above the ground. Then they ask 3.2, calculate the time taken for the ball to reach its highest point. Okay, so it's thrown up at 7,5. Okay, let's act this out, guys. Let's act it out. It's a vector problem. Which direction is positive?
Upwards.
Upwards, positive. So let's write it down. We're going to say upwards is positive. What's the next thing we're going to do? We're going to start listing all our givens. And then what we want to find out. So what is the initial velocity? Its initial velocity is 7.5. Now is it plus or minus? You see, it's very important we make note of it. Okay, so the initial is plus 7,5 meters per unit. What is acceleration in all projectiles? You see, we're getting used to it now. How much? Positive or negative? Negative 9,8. They're asking for B. They tell us when it reaches the top. So Cassie, when it reaches the top, what's its V final? 0, right? Can anyone forget that? Please tell me you're never going to forget that, because if you go away in a week time, you forget that. Why were we here?
Yes, sir.
Why were we here? And believe me, I've taught classes where in a week time, no one remembered what we taught today. It's frightening. I ask myself, why did we bother? So you guys, all you have to do is just revise it occasionally. Okay, so V final at the apex is 0. So then the question becomes, calculate the time taken for the ball to reach its highest point. What formula are we going to use? The first one. How easy peasy is that? And that is for 3 marks and 2 marks. 5 marks of a final exam. So let's write it. V final is V initial. Final is V initial plus a delta T. What is V final? 0. What's V initial? Plus 7,5. What is A? Minus 9,8, and we're trying to find delta T. Take the 7,5 to the other side, what does it become?
Negative.
Becomes minus 7,5 equals minus 9,8 times delta T. Dividing both sides by 9,8 or negative 9,8. Do you see how I work out do you see how I do the changing the subject over formula? I divide both sides by the same thing. Is that how you taught to do it?
Yes, yes.
And then you cancel out. Where? Didn't I?
So I don't do that as long.
There I did. I divided both sides by 9,8. Oh, you mean I left out the negative? Well done. You see how you can screw yourself like this?